Good morning. Am I audible? Somebody please respond. Am I audible?
Yes, sir.
Yes, sir.
Yeah, thank you. Right. We shall start today's one of the good topics that we have in our syllabus. Okay, that's on writing data into a file which is there in the Hadoop file system, distributed file system. So in the last class, I just want to make a review of the last class. So last class we had a discussion regarding how exactly data will move. Data is read from the file. Okay. So normally your HDFS client will send a request, open request to distributed file system HDFS. So automatically your HDFS will first consults the name node, and the name node will certainly get the metadata and get the block locations where which block, where it is stored, in which data node it is stored, all those information, and it will give back to the file distributed file system as a response. And later the same information will be passed on to the file input data stream Java file. The same information is passed on to the Java file. So Java file will contact the respective nodes based on this metadata and get the data. So if there are data nodes, involved are 1 and 2. So suppose the file blocks are involved in stored in almost 10-20 data nodes. So what happens? Your Java file will consult all those data nodes and get the data as a response and pass it on to the HDFS client and close the connection. So this was, and we discussed the program also. So the same thing, a file system get configuration. So configuration will certainly work. So configuration is nothing but based on this configuration only, so you are able to get the metadata. This configuration object is nothing but it is getting the metadata and the block information. Based on this block information, what happens? The files can be read. So from this, and it is associated with the file input stream. So input stream, you are certainly getting the things, and finally you are displaying. This is what we discussed in the last class. And today we are going to read the data from local system. We are going to read from a local system, and the file will be stored, the contents of the file will be stored into the HDFS. So you will read the data from local system and you are trying to write the data in HDFS, using Java program. So the local file system will be transferred to HDFS, and that is the program here. Of course, the same thing. We will discuss this anatomy of file write in the upcoming class. But remember, so whenever you are giving the data to write, what happens that the data first will go to name node, and name node certainly what happens will tell where exactly you have to put the data. So it will give the entire plan how exactly the data should be written. So what happens? The same data will be sent to data node 1, and data node 1 will certainly name node, whatever the name node gives the blocks. So first block is stored, second block is stored, third block is stored. Finally, the same information is returned back as an acknowledgement packet, and same acknowledgement packet will go to the name node. So and that entire process completes. Anyhow, this we will discuss. But we are today we are focusing on how exactly we can make use of this Java program. We'll write Java program, how to copy the local file system to HDFS. So to HDFS, how to copy it. So that is what we are targeting in today's class, right? Okay. So for this, one of the very important thing that you should understand is there is a function called create function. So this create method is associated with the file system data output stream. So what is exactly a file system class? A file system class is a collection of various methods that are associated with file operations. So it has a number of methods for creating the file, modifying the file, updating the file, deleting the file. So of course, updation is not possible, but append is possible. Append, you can add the content, but updation is not possible. So because the Hadoop principle is write once and read many times. Of course, you can append. For the existing content, you can add some more. So that is possible. So the simplest method that we have in this file system class that takes the path of the object for the file to create and return the output stream. So this is the method. Create is the method. Certainly what this create method will do, it will take the entire path and it will return an stream object. It will return a stream object. Stream object is returned. So that is the concept. So and remember, so this has multiple versions. It's an overloaded function. The function, the method what you have, a create method, it is having various overloaded versions. So specifically they forcibly overwrite the existing file, the replication factor of the file, and also the buffer size to use the file to write, and the block size for the file, and various file permissions. All those things, certainly it will overwrite. You can certainly write this for overwriting all this information. There is also an overloaded method for passing a callback interface. Callback in the sense, once the function method execution is done, so entire method execution will, finally, it is just like a trigger in your database system. Once the operation is done, so it will trigger some method. So we call it as progressible method. So callback method, that will certainly, so once the some portion of the the work is done, what happens, it automatically call a progressible function. So progressible is actually another method, so which is a callback method. So after executing the create function, progressible method is called, and that is a callback. Again, after executing progressible will again call the create again. So it is the process. Anyhow, we'll see that in the upcoming example. So this application can be modified for progress of the data being written to the data nodes. Of course, the progressible is another method. It is a method. So certainly create method creates the file, and so while writing the file, okay, you have a lot of data. So once one block of data is written, so progressible method is called. So it will say, so first block is written, so that means there is a 40% improvement. Next, second block is written, another 40%. So totally 80% work is done. Next, another set is written. So finally it will display, okay, 100% it is written. 100% it is written. So you can certainly have, so like this. So this progressible is actually indication of the progress from 0% to 40%, 40 to 80%, 80% to 100%. So that's the concept that you should understand. So that's the concept that you should understand. It's quite important and necessary. And of course, you can see for this, we'll make use of util package. This util package is a special package available in a Apache Hadoop. So it is a package available in Apache Hadoop. So that's why we use. And progressible is actually an interface, so which has a built-in method. So we'll do it. An alternative to create a file. So normally create a file will create the file for if the file size is very small. And if you are working with a streaming set of data, streaming data, what do you mean by streaming data? It's just like you publish one video. Automatically, when the video is going on, or when somebody is talking, maybe our prime minister is talking, or our chief minister is talking, or some person is giving live video. So people will give comments. So comments, whatever the comments are coming, I think you might have seen. So it is a streaming data. Continuously it is flowing. That data is continuously flowing. So whenever you are having continuous stream of data, create function or create method is not sufficient. Because create method will only create the file only once when you have first set of data, first batch of data. For the next batch of data, certainly you have to append. So in order to append data to the existing file, so you can certainly use this method, append method. So, and certainly this append method is associated with, again, FS data output stream. So append method, and you have to give the path. So based on the path, so what happens, the file contents, whatever you give, so it will be appended. We'll see this in the example that we are about to discuss. And the append operation allows a single writer to modify an already written file by opening it and writing the data from the final offset. Final offset means from the end of the file to the next further. You can certainly write. With this application interface that produces unbounded files such as log files, of course, log files also. So every time some event occurs, log entries have to be added. So that can write to an existing file after restart, for example. And the append operation is an optional, and it is not mandatory, but Hadoop for all Hadoop systems, certainly it is maintained. But S3, I think cloud and Amazon S3, simple storage services, S3 we call it as. So that actually do not have this append option on the cloud. Actually, all these things can be implemented on the cloud. Okay, anyhow, let us see the program first. So the name of the file that we are giving Java file is that is file progress, file copy with progress. So this is the file name. So what happens as the copy happens, the file copy happens, so there will be a progress bar. There will be a progress bar written. Okay, shown. Right. Okay. So you are having a main function. So in the main function, you take string arguments. Arguments are very important because these arguments only. So what you'll do, you'll give the source file, you'll give the destination file. Source file will be local file system. From the local file system, destination file will be on HDFS. So you are trying to read from local file system, from the operating system, from OS, and you copy the contents of that file to Hadoop distributed file system. So that is what you are doing in this particular program. So what you are doing, the first argument you call it as local source file. You are calling, and it is a string. Okay, right. Secondly, you are taking the destination. Destination as argument 1, So the second file in the argument list is actually the destination file. So normally destination file, you will be giving the file name that has to be stored in HDFS. Okay, right. That's done. And you know this input stream buffer. Okay, so this is, I think, you know very well from Java. So with this object, what you can do, this object will open the file that is in the local source file will be opened, and the file input stream, it is associated with file input stream. The same thing will be stored in buffer input stream. So that will be stored, right? And after this, the configuration information, this is very, very important. During this configuration object only, your program will come to know, you know, where the data has to be written. So what should be the number of blocks, and where the first block should be stored in which data node, where the second data node has to be, the second block has to be stored in which data node, where the third block is to be stored in the you know, third or fourth you know, data node. So where, which block in which data node, that information, and the same entry, it has to be made in name node. So name node, it has to be done. So this configuration is a built-in Hadoop configuration you know method. So that will certainly return the entire configuration of file operation, of course. So with the configuration operation, what you are doing, you are getting the you know, you are creating, look at here, URI.create the destination, you are going to create it. So you are going to get file system fs. So file system.get. So get is to get the entire location of all those information, you know, information to create the destination file through this configuration. This will be very useful for writing the contents. So this you are going to get from the name node. This you will going to get from the name node. So name node will return the entire details, and it is stored in FS, the file system object. Now, using this file system object, fs.create, you are going to create. What is that you are creating? You are creating the destination file. You are going to create the destination file using the path method. Yes. And it is a callback. Once the file is created, so what happens? A 10% is done. Then file contents are written, 20% is done. Next, file second block is written, 40% is done. Third block is written, 80% is done. Final block is written, 100% is done. So every time the progressible, what it is showing, it is a method that will display the progress of the write operation. So in the progressible you know, method, what you are doing, so it is actually a callback method. In the progress method, what you are doing, you are writing dots. So if one operation is done, one dot will be displayed. The second operation is done, second dot. Third operation, third dot. Fourth operation, fourth dot. Fifth operation, fifth dot. So last operation, sixth dot. Finally, everything is done. So it will do. Suppose if the file size is very less, it is written straight away. Sometimes progress is not going to work. Okay. If the file operation, if the write operation is taking more time, then this progress will certainly display. And that's all. So it creates, and once it is created, one dot. Next, once it is created, done. Next, IO input output utils dot copy bytes. So from the output, from the input file, it has to copy to the output file of 4096 bytes. So that means 4 KB of data is copied, and this will continue until the data is available. Yes, that's why it is saying true. It is giving the true message. It is displaying true message because it is continuing. And finally, it finishes. So this is the program, and in the examination, definitely they will ask Java program implementation to read the data from HDFS file system and display, or to write the data into the HDFS file system, create and write the data. So here, what you are doing here, you are creating. Here you are creating. Yes, here you are creating the file, and here you are writing the file. You can see you are copying the file from input, that is local system, to the destination system. So this is local, and this is HDFS file system. HDFS file system. So that is, you have to understand, this is local, from local to HDFS file system at once, 4096 bytes. So it is written, and it is available. You can see it is available. The same program I can certainly demonstrate. In the next, and of course you can see. Typically, you can give Hadoop the name of the file, that is file copy with progress. That is the name of the class file. You will give the local file path, and the destination file path. So when you do, it will, suppose this file is almost very big file. Imagine it is a around 8 GB file. So what happens? 4,000 bytes, 4,000, 4 KB, 4 KB, 4 KB. So many times it is copying. So what happens? It is keep on moving the dots with the progress. So it moves just like this. It moves. So during the writes. So same thing I will be demonstrating in my Hadoop system. So Hadoop virtual machine, I will switch on to now Hadoop machine. So I think you can see there. I'm just Hadoop virtual machine is already running. Yes, you can see it is already running. Yes, I just yeah, it is already running. Yeah, Hadoop. It is actually Cloudera. It's a version of one of the Hadoop instances. So certainly, what I do, I just open this. Yeah, a file is already there. Yeah, it's already there. Yes. So now I open the terminal. Okay. Anyhow, I open the terminal. So terminal, I'll just open the terminal. You can see, I'll give some, I'll see some local files. There are so many files that are there in the local system. So test Surya, okay. I just create. Okay. Today, I'll just, today I believe some people are celebrating Narasimha Swami Jayanti. So certainly I just create a file. So gedit, Narasimha Swami N Swami .txt. Sorry, gedit N Swami.txt, Narasimhaswami.txt. Certainly I type. So hello all this is a sample file. Happy Narasimha Swami Jayanti. Okay. May all bless you. Okay, right. Some information I just store it, and I store it as nswami.txt. I just save it. Okay. So now in the local system, nswami.txt, somewhere it is there. ENABCST. Okay. RPQRST. Yeah. nswami.txt. Just now I have created. nswami.txt. So what I'll do, I'll open my Java Eclipse. So I have already installed this Eclipse. So by double clicking the Eclipse, certainly I will open Eclipse. So here what I do, so I'll just I just give the Okay, file name nswami.txt. nswami.txt. Yes. So this is file cat. Okay, leave it. Okay. I just write it as from the local file system, from the local file home training Eclipse workspace. So I have a file called nswami.txt. So I copy the same file system file to the same in the same folder. I can just copy the same file. Okay. So what I do, I go to the same system. Okay. File directory somewhere, archive manager or file manager, or else the same file contents. I just copy it. Okay, you can just see. Just copy it. I'm sorry. I just copy it. Okay. Gedit nswami.txt. I just copy the contents. Okay. Same contents. I just create it here. You can see. So along with the file, what I do, I create a new file. Where is it? New file. Yes, it's here. So nswami.txt is the file. Okay, just create a file. So nswami.txt, I just open the file. File is open. I paste all the contents. Okay. Hello all. This is a sample file. Okay. Save. I'll save the file. Okay. Certainly I have done. So this file nswami.txt is a file that is available in local system. You can see this is a home directory, root Eclipse workspace. Name of the file is nswami.txt. I'll just write it. nswami.txt, the name of the file. The same file I had to copy it to Hadoop. You can see HDFS localhost 8020, because the name of the port number, the server, Hadoop server is running on this. The client and user training, it has to go to user training, and the name of the file is nswami.txt. Yes. So instead of there, I have given argument 0, argument 1. So argument 0 is nothing but the source file. So source file is nothing but your local file. This is the destination file. So nswami.txt using this Hadoop it is available. So now what I do, I just run this program. Save as, I'll just save the file. Yes, and I run this Java program. When I run this Java program, what happens? That yes, the program completed. So file, the terminated, automatically the entire file from local system, it has written to the training, that is Hadoop system. How to check whether it is written or not? Yesterday we have written a program to read the contents from the Hadoop. So Hadoop file. So let us open the same Hadoop file. Hadoop file. I just copy the same thing. You can see I just copy the same thing to the file read program. File read program. I'll give the contents from I'll give the path, entire path. So when I give the the same file here, so it will read. This program will cat means it will read. So it will read the contents from nswami.txt, which is available in Hadoop. So if it is copied and created, definitely it should be there. Or you can check in the this one also. So Hadoop FS, what do you say? Hadoop FS minus ls, you certainly give. This is a Hadoop command you can certainly give. So when you give Hadoop file system, so you can see, oh, I think, sorry, I had to reduce the size. Okay. Okay. Now, You can see there should, yeah, nswami.txt is available. So it is a 84 byte file. So it is there. So this is, I'm getting the Hadoop files list. Okay, in the Hadoop files list, so the file is already there. Yes, file is copied. Okay, from the local system it is copied to um, Hadoop system. Now same, I just run this program. So definitely the contents of what I have copied earlier in the previous program, it should display now. Yeah, it should display now. Yes, the contents we got. Hello all, this is a sample file. Happy Nasima Swami Jayanti. May all bless you. So this is the contents that I am getting from the file which is there in the Hadoop distributed file system, HDFS. So this is the program to write the file from local to the Hadoop system. And once it is written, just to get the confirmation, I'm running the read program, which is reading the contents from Hadoop file system. Hadoop file system, and it is displaying. That means it is successfully copied, successfully listed here, and successfully displayed the contents here. So this is what the program, Java program, to write the contents, from local file system to the Hadoop file system. So that's all for today's class. So have a wonderful day, and all the videos, class lectures will be available in this particular website. All your study material like PPT, everything is available in this website. So another 10 to 11 classes I need to complete module 5. So next class I'll be completing module 4, and after that I may require another 10 classes to complete module 5. So once it is done, so you can certainly we can concentrate on preparation towards the examination, and how exactly we have to do. So actually yesterday VTU has notified that the exams will going to held during June and July. So obviously we will get very few time after lockdown is lifted. So be prepared from now onwards. Be prepared, and we will certainly have all those preparations done. So that's all for today's class. Have a wonderful day. Thank you.